Section 6.2, the normal model. For the section 6.1, we introduced two types of the data, the discrete and continuous. For the discrete probability, we know how to create the probability distribution to find the probabilities. And under the continuous random variable, we do have a uniform distribution and the normal distribution. For the uniform distribution, we will create the rectangular shape to find the probabilities. And for section 6.2, we'll be focusing on the normal distribution. The normal model, one of the most widely used probability models for continuous numerical random variables, also called the bell curve because of its shape. Visualizing the normal model. So look at this histogram. This is the histogram shows height of a sample of males. You know this is a symmetric, means when you cut it half, the left hand side is going to be similar to the right hand side here. And this is unimodel. And we call this as the normal distribution because it looks like the bell shape here. The normal distribution, same mean, different standard deviation. So we have two different normal distribution. Both of them looks like the bell shape. The red one, we have the mean here, but we do have a smaller standard deviation. For the blue one, they do have the same mean, just like the red one here, right? But the blue one, we do have a larger standard deviation. And then the area under both curve is going to be equal to 1. Okay, remember that under the area here, it has to be equal to 1 because this is a density curve. Okay, let's talk about the notation. We'll be using the x bar has a sample mean, right? X bar, this is going to be the sample mean. And then we're going to use the mu has the population mean. I need you guys remember all the notation. Okay, sample mean will be using the x bar. Population mean will be using the mu here. For the sample standard deviation, that's S. Okay, S represents sample standard deviation. And we'll be using the sigma. This is called the sigma. Has the population standard deviation. Okay, make sure you guys know how to write the sigma. Okay, sigma. Some students use the theta. Okay, theta is going to be looks like that one. This is not the theta. This is the sigma. Sigma represent the population standard deviation. First part, standard normal distribution. Later on, we're going to talk about the non-standard normal distribution. Okay, what is a standard normal distribution? Standard normal distribution means we do have the population mean equal to 0 and population standard deviation equal to 1. Okay, I want you guys to highlight these two. Okay, the requirement for the standard normal distribution, population mean has to be equal to 0. Population standard deviation has to be equal to 1. And of course, the total area under the curve has to be equal to 1 as well. Okay? So one more time, population mean talking about here in the middle. The mean equal to 0. And when you add 1 standard deviation here, 0 plus 1, which is going to be equal to 1. 1 standard deviation, 2 standard deviation, 3 standard deviation. And then this is a mean minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. And then keep in mind that the total area under the curve has to be equal to 1. Okay? And then the standard normal distribution, since the mean equal to 0, standard deviation equal to 1, it would be equivalent to the c-score. Remember what is a c-score? C-score is the measure how many standard deviation above or below the mean. Okay, first part. They will be given the c-score and then we want to find the area to the left or to the right. Okay, so highlight this one. This is how you guys using your calculator. to find the area to the left or to the right. I will show you guys later on, okay? So they will be given the z-score and you want to find the area. Look at this example. Okay, so I draw the line here. When the z-score equal to 0, I want you guys find out the area to the left. So here. So think about it. You know that the area under the curve has to be equal to 1. If I cut it half, I could use 1 divided by 2, which is going to be 0.5. Right? So if we use the calculator to find the area to the left, has to be equal to 0.5. So what we're going to do? First, go to the second vase and then go to the normal CDF. Okay, I'm going to show you guys after this instruction. And then you're going to plug in the lower value and the upper value. Lower value and upper value, this is talking about always from the left to the right. Okay, so if I want to find the area of this part, my lower value will be here. Upper value with a 0. How can we represent this part here? We'll be using the negative 1D99. This is the scientific notation. Okay, negative 1D99, this is the scientific notation. It will present negative 1 times 10 to the power of 99. Okay, so this is really small number. Okay, the lower value will be negative 1D99. The upper value will be the z-score, okay, which is going to be the 0 here. So we want to use the calculator to find the area cumulative from this point until 0. Means like here. Okay, so when you write on an area to the left, normal CDF, negative 1D99 to the right. Make sure the lower value and the upper value is always from the left to the right. Okay, don't switch these two guys. The order doesn't matter. Okay, let's look at my calculator here. First, you're going to go to second vase. Second vase. And then you're going to see normal PDF and normal CDF, okay? PDF is talking about at that point. CDF is going to be cumulative area from the left to the right. So I'm going to choose number 2 here. And then I'm going to plug in negative 1D99. So negative, use the 1 below the 3 here. Don't use the minus side, okay? Negative 1. And then the yi, you will find it from the comma. Did you see it from the comma here? So I'm going to use second comma for the yi, and then 9. And then comma, cumulative from this point until 0. Okay, so enter, you're going to get 0.5 here, 0.5. Okay, area to the right, same idea. Area to the right, my lower value will become 0. Okay, I want to find the area to the right here. So starting from the 0, lower value, upper value, that will be positive 1D99. So do it one more time. Second vase, click on number 2, starting from 0, comma, positive 1, second comma for the yi, 99, enter. So you're gonna see that will be 0.4099999. So you wind up like 1 decimal space, that will be 0.5 also. Okay, this is how you guys using your calculator to find the area to the left or to the right. Okay, example 1, using calculator to find the area to the left of z equal to 1.26. So first, scratch the picture here, the bell shape. 1.26, so 1 is here, 1.26 is somewhere like here. And then we want to find the area to the left, okay? So we're looking for this part here. Okay, so write it down. I want to find probability that the z-score, okay? Z-score talking about this point, less than 1.26 means like I want to find the area under this part. Okay, one more time. Probability means the area. I want to find the area, the z-score less than because I'm looking for the area to the left, 1.26. That would be equal to normal CDF. So starting at this point, negative 1E99 until, what is the upper value? That would be 1.26. Okay, use your calculator. You should get 0.8962. Okay, I need you guys write this one on your exam. I need to see the whole process. What you're gonna plug it in, what you're looking for, and then what is your final answer. And usually for the area, we want it to the 4 decimal space. Next one. Use calculator to find the area to the right. This time, area to the right. When your z-score equal to negative 0.58. Okay, I want you guys try to do it by yourself. So this is a negative 0.58 and I'm looking for the area to the right, okay? So what it done, this time there will be the probability z-score greater than, okay? Because we are looking for the area to the right. So z-score greater than negative 0.58 equal to normal CDF. What is your lower value? Lower value will be this point, right? Upper value will be 1E99. Okay, use your calculator. You should get 0.7190. Okay, if you're done, I want you guys try to do the example 3. This time, I want to find the area in between. Okay, draw the picture here. Shape the area, which part of the area you are looking for. How you write the probability in here, okay? Greater than will be the area to the right. Less than will be area to the left. So how can you indicate in between? Okay, negative 1.45 and 0.42. So this is the area you're looking for. Okay, first write it down. Which part of the probability you're looking for? So probability that the z-score is in between negative 1.45 to 0.42. And then normal CDF, lower value will be this point, upper value will be this point. Use the calculator. You should get 0.5892. So this free example, they given the z-score and you want to find the area. So this is what we cover from the example 1 to example 3. Given z-score and then find the area. Second part, this time they were given the area and I want you guys to find out the z-score. So we'll be using the inverse norm, okay? Inverse norm. Norm means normal distribution. Okay, so here inverse norm, you're gonna plug in area to the left. Okay, if you're using the TI-83, you have to plug in the area to the left. If you're using the TI-84, some calculator will ask you, you plug in area to the left or area to the right. Okay, it really depends on your calculator. So please try on your calculator to see if your calculator need to plug in area to the left or area to the right, okay? Okay, use calculator to find the z-score that has an area of 0.2643 to its left. Okay, so first, think about it. I need to draw the picture here. They're talking about an area 0.264 feet to its left. So, what do you guys think which picture is gonna be correct? Think about it. The total area under the curve is gonna be 1, right? When I cut it half, it's gonna be 0.5, right? Right now, they're talking about 0.2643 to its left, okay? 0.2643, which is less than 0.5, okay? So if half of it is gonna be 0.5, and this picture, it doesn't work, right? It's gonna be more than 0.5. So this is wrong. We will have this picture. Okay? Then they given the area and you need to find the z-score here. Okay, so first we're gonna write it down. Probability of z less than something. This is the z-score we are looking for. Less than because we know the area to the left is gonna be 0.2643, right? So z will be equal to inverse norm. Plug in the area to the left. Okay, let's try to do it together using the calculator. So first, go to the second vase, and then we're gonna choose number 3 for inverse norm. And then we're gonna plug in the area to the left, so 0.2643. Enter. So the z-score is gonna be negative 0.63. Okay, negative 0.63. So it makes sense here, right? Because like in the middle here, the z-score is 0. So on your left hand side, the z-score should have the negative. Okay, z-score will be equal to negative 0.63. Okay, example 5. Use calculator to find the z-score that has an area of 0.68 to its right. Okay, 0.68 to its right. So I have these two pictures. Think about it, which one is going to be the correct one. Okay, so this is wrong, right? Because half of the area is going to be 0.5. 0.68 should be greater than 0.5, so it should be this picture. So you have the idea that your z-score should be negative, okay, equal to negative. Okay, the given the area to the right is 0.68, and you need to find the z-score. So I'm gonna write it like this way. The z-score greater than something is equal to 0.68. So think about it. When we're using the calculator, we want to plug in the area to the left. How can you find the area to the left? The total area under the curve is going to be 1, right? So we could use 1 minus 0.68. So here the z-score will be equal to inverse norm 1 minus 0.68 because we are plugging the area to the left here. Use your calculator. you're gonna get negative 0.47. Okay, example 6. Find the z-score corresponding to P85. The 85 percentile. Remember what is a percentile? Percentile is talking about the graph. You're going to cut it into 100 pieces. The area of each pieces will be equal to 1%. So P85 is talking about like 85% to the left. Okay. So 85 percentile means 0.85, the area. So the line is somewhere like here. Okay, one more time. Percentile means you're gonna cut it into 100 pieces. And for each area of the pieces will be equal to 1%. So when you add it all up, will be 100%. So 85 percentile is talking about the area to the left, it's gonna be 0.85. And then we want to find the z-score. Try to do it by yourself. Okay. Z-score less than P85. Okay, the percentile equal to 0.85. So what is z-score equal to? Inverse norm. Area to the left is going to be 0.85. Use your calculator. You should get 1.04. Okay, so for the first 6 example, we talk about the standard normal distribution. Remember what is a standard normal distribution? The population mean will be equal to 0. Population standard deviation has to be equal to 1. And then they given the z-score, you should be able to find the area. Or they given the area, you should be able to find out the z-score. Okay, make sure you guys know how to do it. We will have it on the exam. Second part, we're gonna talk about non-standard normal distribution. When working with a normal distribution that is non-standard with a mean difference from 0 and or standard deviation is different from 1, we will transform a value x to a z-score. Okay, this time we will have the value of x because this is non-standard normal distribution. So how can we transform the x to a z-score? We'll be using this formula. Okay, z-score equal to x minus the mean divided by the standard deviation. Okay, highlight this formula. You guys need it in the future. So when we have a non-standard normal distribution, we will have the mean and then we also have the x in here. Okay, the mean is not equal to 0. Okay, and then we do have the value of x somewhere. So if we want to convert it to the standard normal distribution, we will apply this formula. Then your mean will become 0. Your x will become this z-score here. Okay, non-standard normal distribution, we could convert it to the standard normal distribution. Okay, look at this example. Height in a certain population of women follow a normal distribution with the population mean equal to 64 inch and population standard deviation equal to 3 inch. A randomly selected woman has a height of x equal to 67 inch. Find and interpret the z-score of this value. Okay, so first, the mean is not equal to 0. Standard deviation is not equal to 1. We already know this is non-standard normal distribution. And that's why we do have the x in here. I want you guys to find out what is the z-score. Means when I plug into this formula, find out what is your z-score equal to when x equal to 67 inch. And then interpret this value. And what does that mean? Okay, so let's do it together. we have the non-standard normal distribution. The mean is always in the middle here. And then x 67, so greater than this guy, so somewhere like here. And we want to convert it to the standard normal distribution. Z-score will become 0. Okay, so this guy, we're gonna plug into this formula. When you guys try, plug it in, tell me what you guys get for the Z-score. So x equal to 67 minus the mean, 64, divided by the standard deviation. You could get 1 here. Okay? So from the picture, x equal to 67, this is equal to the z-score equal to 1. Okay, we already find the z-score. Now we need to interpret the z-score. What does that mean? We could say a height of 67 inch is 1 standard deviation above the mean height of 64 inch. Okay, 1 standard deviation above the mean. Okay, so review a little bit. They given the z-score and you want to find the area. What you gonna put in the calculator? We'll be using normal CDF, right? Lower value and upper value. If they given the area and you want to find the z-score, what you gonna put on your calculator? That will be inverse norm, right? Inverse norm, area from the left. Okay, how about this time? Given the x, if you want to find the area, okay, when you see the x, that means this is a non-standard normal distribution. So what we're gonna do, given the x values, find the probability, means find the area. So we'll be using the same thing, just like the number 1 here. We'll be using second bars, normal CDF. We still put in the lower value and upper value. The difference is, this is the non-standard normal distribution. So we're gonna plug in the mean and the standard deviation. Okay, exactly the same thing with the number 1. It's just for the number 1, that's a standard normal distribution. We know mean equal to 0, standard deviation equal to 1. So we don't have to plug it in here. But since this is a non-standard normal distribution, so we have to plug in the mean and the standard deviation. Okay. Okay, try the example. Height in a certain population of women follow a normal distribution with the mean 64 inch and the standard deviation equal to 3 inch. Find the probability that a randomly selected woman has height less than 67 inch. So we only pick one woman, okay? And her height is less than 67 inch. So I will have this picture here. X is equal to 67. And then remember, find the probability means find the area. So find the area with less than. So we are looking for the area to the left. So they given the x and I want you guys find out the area. So we'll be using the normal CDF, right? So first, write it down. Probability that when your x less than 67 means we want to find the area to the left. Equal to normal CDF. Lower value, negative 199 to 67. And then the mean, which is 64, standard deviation, which is gonna be 3 here. Okay, you should get 0.8413. Okay, I want you guys try to do the B. Make sure you will have the density curve here. Okay, this is called the density curve. On the exam, I need you guys show me the picture. Show me what you are looking for and what you're gonna plug it into your calculator and then the final answer. Okay, keep in mind that area we always use 4 decimal space. C-squared we usually use 2 decimal space. Okay, try this one. Try the B. If you can do it, do the C also. Okay, B. Find the probability that a randomly select woman has a height more than 70 inch. Okay, more than. So which part of the area you're looking for? More than. So it's going to be on the right, right? This is what we're looking for. So how can you write down this guy here? Probability that x greater than 70, right? Because we're looking for the area to the right. We'll be using normal CDF. So what is the lower value? Talking about x equal to 70, upper value will be positive 1e99, and then the mean, and then the standard deviation. Okay, 70 is the lower value. Upper value, 1e99. Then the mean, and then the standard deviation. Use your calculator, you should get 0.0228. Okay, last one. Find the area is between 61 and 67. Okay, so x is between 61 to 67. Use the normal CDF. Lower value will be 61, upper value will be 67. And then make sure you plug in the mean and the standard deviation. So you got 0.6827. Okay, right? This is how you guys working on the non-standard normal distribution. When they given the x, you want to find the area. Okay. Okay, number 4, when you have the non-standard normal distribution, this time they given the area and you want to find out the x. Okay, so same idea with the number 2 here. This is the standard normal and this is non-standard normal. So same thing, you're gonna plug in area from the left. Okay, using the inverse norm, area from the left, you need to plug in the mean and the standard deviation. Okay, try the example 9. Mensa is organization whose membership is limited to the people whose IQ is in the top 2% of the population. Assume that scored on an IQ test are normally distributed with the mean equal to 100 and the standard deviation equal to 15. What is the minimum score need to qualify for membership in Mensa? Okay, so think about it. First, this is the standard normal distribution or non-standard normal distribution? Non-standard, right? Because they have the mean not equal to 0, standard deviation not equal to 1. So you know this is a non-standard normal distribution. So non-standards, you're gonna look at number 3 and number 4. Are they looking for the area or are they looking for the x? Do they given the x in here? No, right? The minimum score, this is represent your x. They want to find the x, need to qualify for the membership in Mensa. So they already given the area here. This is a top 2% of the populations. So the picture is gonna be here, top 2%. It's talking about like here. So they given the area to the right, and I want you guys find out the value of the x. So first, area to the right is 2%. What is the area to the left? Total should be 100%, right? If this is a 2%, so you know this guy should be 98%, right? Or 1 minus 0.02, which is going to be 0.98. Now, they given the area to the left, and I want you guys find out the value of x. So x, you could put greater than, right? Because this is what they given, equal to 0.02. X will be equal to inverse norm. I'm gonna plug in area to the left, the mean, and the standard deviation. Use the calculator. You should get 130.81. And then IQ score is always be the whole number. So we're gonna round it up to 131. So this is the example. They given the area and then find the value of x. Okay, last one. Try to do it by yourself. Okay, I need the picture. I need you guys show me what you're looking for, how you plug in to the calculator, and also the final answer. Okay, example 10. The birth lengths of newborn seal pups with mean equal to 29.5 and the standard deviation equal to 1.2. Suppose pups with lengths at the 15th percentile and below are unlikely to survive. What birth lengths would make it unlikely that a pup could survive? 1 to 2 decimal space. Okay, you have the mean and the standard deviation. And then they say, suppose pups with the length at the 15th percentile. Okay, 15%. So somewhere like here. 15th percentile, talking about area to the left, will be 0.15. And you want to find the x in here. Okay, so we're looking for when x less than something equal to 0.15, okay, 0.15. So we'll be using x equal to inverse norm, 0.15, the mean, and the standard deviation. So you're gonna get 28.26. Okay, so for these sessions, you guys learn the standard normal distribution and the non-standard normal distribution. Keep in mind that you have to know how to do it with these sessions, because later on we will apply the knowledge from this chapter to the chapter 7 and chapter 8. And for sure, you guys gonna see this kind of the question on your midterm. That's it.